Now, let us see the second chemical reaction, decomposition reaction. Single reactant produces two or simpler products, called decomposition reaction. The general representation of decomposition reaction is A, B equals A plus B. Remember that decomposition reactions are carried out by applying heat or light or electricity, which provide energy, to break a compound into two or more simpler compounds. The general representation of decomposition reaction for heat, electricity, or light is A, B gives A plus B reaction on applying heating, or A, B gives A plus B reaction on applying electricity, or A, B gives A plus B reaction on applying light. Please note that decomposition reaction is just opposite to combination reaction. It means a combination reaction takes in between two or more reactants to produce single product, whereas, in decomposition reaction single reactant produce two or more simpler products. Here are some examples for decomposition reactions with experiments. Example 1. Decomposition reaction by the action of heat. When calcium carbonate is heated, it decomposes to give calcium oxide and carbon dioxide. The word equation is calcium carbonate on heating gives calcium oxide plus carbon dioxide. Here on left hand side, calcium carbonate compound is reactant, and right hand side calcium oxide, carbon dioxide compounds are products. The chemical equation is: in this reaction, single compound, that is, calcium carbonate on heating, decompose to produce two compounds, calcium oxide and carbon dioxide. By this reaction we can conclude that, when a decomposition reaction is carried out by heating, it is called thermal decomposition reaction. Let us do an experiment to understand the decomposition reaction by the action of heat with ferrous sulfate. For this experiment, we need the following apparatus: boiling tube, test tube holder, and Bunsen burner. The chemicals required are ferrous sulfate crystals, litmus paper blue and red, and potassium dichromate paper, cobalt chloride paper. We need to take precautions while during this experiment. Like, during the experiment, the mouth of the test tube should not point towards you or the fellow students. As soon as the experiment is completed, place the test tube containing ferrous sulfate outside the laboratory. It is necessary, as the gases causes harm to you. Let us start the experiment now. Take a clean and dry boiling tube and add about 2 grams of ferrous sulfate crystals. Note the color of ferrous sulfate crystals, that is light green color. Hold the boiling tube with a test tube holder and heat it with the help of Bunsen burner until the steam fumes are given out. While heating, tiny droplets of a colorless liquid settles near the neck of the test tube. Test the liquid with the following and observe the changes: blue litmus paper, red litmus paper, cobalt chloride paper. When we test the colorless droplets liquid with blue litmus and red litmus, we observe no change in color, and when we touch the same liquid with cobalt chloride paper, it changes to pink color. When steamy fumes stop coming, reheat the test tube strongly for a few minutes and smell the gas slowly. Test the gas with acidified potassium dichromate paper. Observe the color of the residue in the boiling tube. When we test the gas, by passing the acidified potassium dichromate paper to the gas, its color changes from orange to green. The chemical equation of this reaction is: the conclusions of this experiment is: a colorless tiny droplet of the liquid is water, as water is neutral to blue and red litmus paper. When the boiling tube strongly heated, colorless but fumes strongly in air. These colorless fumes in air are called sulfur trioxide. The residue in the test tube, which is reddish brown in color, is called ferric oxide. The colorless fumes, which cause sensation of cough, are called sulfur dioxide. As potassium dichromate paper changes from orange to green, it means the fumes contain sulfur dioxide, that is SO2, gas. As ferrous sulfate on heating decomposes to ferric oxide, sulfur dioxide, and sulfur dioxide, that is single reactant, decompose to two or more products. So, this reaction